Hi guys, welcome to our fourth part in moving to the GitHub CI. Um, I noticed the recording, the sound, the volume is not particularly brilliant. I don't, I don't really have the previous microphone. I don't know what I've done with it, so we're gonna have to somehow survive on that for a little bit. So since the last video, we've pushed a few things. Um, let's have a quick look. So we this is with the work in the previous video where more or less removed most of the relational model. A couple of mop-up exercises, nothing particularly major, just a few bits that we didn't remove during the video. And so the second part of the exercise will be to remove, I don't think it's fair to clock all of this. We probably only did about maybe 20 minutes or so. Before getting sidetracked with something else. So what I was saying was we are in the second task. I don't think there's anything else left to do with the relational support. So we're in the second task, which is to remove boost DI. Let's double check we're recording, and that looks fine. So to remove boost DI, this should be quite simple, hopefully, because I think the only thing we have on boost DI is a couple of interfaces in the application itself, probably CLI, I think. I think we have a factory, which is this guy here, the injector factory. And I wonder even if that's it, actually. I wonder if there's perhaps another factory in the orchestration engine. Oh yeah, there is. Okay, cool. So we got two of these guys. And the idea here is that we have an interface, and this is just binding to the interface. Presumably, we should have something like in the main. Somebody should probably be calling the injector area to obtain. So here we just call the injector to obtain the command line parser. Then we parse. In fact, to be honest, this might not even require an initializer really, because the initializer was there. In fact, why would we have an initializer? Let's try to have a look at the initializer pattern. So the initializer pattern was something that we did originally. Because there was a lot of static state. So for instance, you can see here that in the text subsystem, we need to initialize a whole lot of helpers. And then we need to initialize all of our text transforms. Yeah, that's what it was. Okay, so it's all slowly coming back to me. So the idea was that we had a very large number of text transforms, all of which registered with the orchestration engine. Well, registered with the registrar somewhere, and then we would request those transforms to tell us what was available. Because in the past, our idea was that the physical meta model was considered to be static, was defined at compile time. So we were slowly moving away from this approach. But in the past, the idea was that the physical meta model and the physical model were set in stone at each compilation. And the geometry of the physical meta model and of the physical model was defined by the set of transforms that we had. So, as an example, in the physical meta model, we have parts and we have technical spaces and we have all these constructs. And then in the physical model, we instantiate these with specific model to text transforms. And the idea being that the code generator would define all these things at compile time, and then they would register themselves because we know exactly what they are, and then we would bind with the user models. We would bind to the geometry of physical space. However, what we now understood is that whilst the physical meta model itself is very much set in stone, the physical model is actually quite dynamic, and we have a story for this, which I'm not going to discuss in too much detail right now because it's still early days. But we have a story where we're investigating the possibility of having dynamic interpretation of the physical model. And the idea being that the user could supply a physical model, and that physical model binds to the physical meta model, and you could override any of the templates and so on. But that's all still kind of very much up in the air at the moment. So let's not try to get that work conflated with the current work. The current work is just to try to get things up and running so that we can compile and we have a CI. And that's really long-term visionary work. So all we need to do here, I think, is we need to replace the cases where the the boost DI is being used to inject. Let's have a look again. Where we are injecting. It's been a while actually since I recorded the video, and it takes quite a lot of brain power when you're not used to recording. So I think we just need, in fact, to be honest, one very simple thing we can do is we can just remove the boost DI classes, a bit like we did yesterday with the previous video with the relational model. We can do something really simple. We could just remove reference to boost DI, see what breaks, and then replace those things with some kind of hard-coded approach. I think we've got grep somewhere around here. Here we are, and we already have grep for boost DI. So what I'm going to do is I'm going to might even go as far as saying let's just remember this somewhere here in Scratch perhaps. I might go as far as saying is let's just remove in modeling 7 perhaps. That's 8. Got quite a few areas open. So best thing to do is to remove the injectors that are coming from boost DI. We have a couple of these, one in CLI and one in orchestration. So if I just go up to let's have a look to CLI, and we'll do the one at a time in fact. So if I just go to CLI, look at the model, look for an injector. Here we are, there's an injector factory here. I'm just literally going to remove this guy here. And then I'm going to regenerate everything. And so all this will do is it's going to delete, as you can hopefully see here, it's going to delete that injector factory we saw a second ago. The job of the injector factory was merely to instantiate the option parser. So I'm going to take this code and then we will just break, see what happens when we try to compile. This is going to break, of course, main. And then in main, we'll say, well, there is no such thing as an injector factory. I'll paste this stuff here. And then I'll say, well, here's the command line options parser coming from CLI. And if you could just use the command line options parser. Something like this, right? So no more DI as such. We will merely create a parser. And because this is now in the stack, we don't even have to worry about this anymore. And I will remove this fix me here because as you can see, we're no longer going to move to DI. It's not that simple. So we will, interestingly enough, this comment, actually, let's just not do that right now. Just so our diff doesn't become messy. So what we'll do then is just this, and hopefully what this will do is, right, so program options parser tests also seems to rely on this factory. Not sure why, to be honest, but interestingly enough, we may not be able to do this one at a time because the application itself was using the injector. Actually, I wonder what happens if I literally just create an application. So if I just say const application app, and then right, so this is now complaining about something. Okay, so best thing to do is probably to just jump over to our programming area, look at main. Right, so this guy is telling us that we need some kind of constructor in order to create this. I assume this constructor probably is going to require the parser. Let's have a quick look at what it says. Oh no, actually we need not the parser, but all the other chaps. Converter and so on. Okay, that's fine. We will do something really, really simple here. Let's just instantiate these guys. I'm slightly surprised that we need those three guys, because as you can see here, we only see the command line parser. Clearly there's another factory somewhere where the other three guys are being created. Ah, it's probably the orchestration. Okay, that's fine. So we need to do both at the same time. That's fine, it's not a problem. Let's just jump over to the modeling area. Let's open up our orchestration project and open up the model, and we will find there's another injector factory here. We will get rid of the injector factory. Before we regenerate, well, actually we will just regenerate. So we'd regenerate all models. Then if we just quickly go up to Git, you see that these guys here got deleted. We can copy these guys and go back to the command, so the entry point, and in here what we'll do is we'll say, well, let's just access whatever we need to access directly, and then I guess we just need to create these three guys. So in effect we just replaced sort of dependency injection with manual generation of all of these chaps here. Interesting that we don't seem to know about orchestration. Let's just, okay, that's better. I am actually doing this the simplest possible way. I'm sure you probably disagree with this simplistic approach, but just to get us going again. Okay, so that seems to be good enough to compile. It's nothing clever really. It's very, very, very trivial really. So I'm sure that if you were to do this properly, especially if you had something like C#, we would do something a lot more involved. But this is C++, and I think it's the good. Oops, we wanted the program options parser. That's the guy. Let's call this P. As I say, when we're coding something like C#, then we tend to make things a lot more clever, I guess. That's mainly because languages like C#, they allow you to do, well, they're basically dynamic runtime languages, I guess. C++ can be used that way, of course. I could easily create a proper interface with a proper DI framework and so on. And we're trying to move towards that. But I think sometimes you should try to use the language, the strengths of the language really. C++ strength is the ability to do a lot of compile time programming, and that's why that's one reason why I was quite interested in Boost DI, because it does give you DI, but it does a lot of compile time DI, whereas languages like C#, actually I think there's something happening here. Let's just put it on pause for a second. Okay, just the usual interruptions. So now, as I was saying, so the good thing about C++ is that you can rely on compile time rather than just runtime, and that's a big advantage, really, having the option, especially when you have a limited number of cases. I mean, the type of sort of enterprise development, you tend to have one interface with 20 implementations, lots and lots of um, complication in terms of the UI, lots of options, and it's actually quite convoluted. But in our case, we got such a simple code base. The AI is mainly being used. Well, it's mainly exploratory, really. And going forwards, we probably won't even need registration as such, as I was trying to explain in the previous when I was alluding to the injectors. So I think this is probably the end of Boost DI. I think. Let's have a quick look at what. In fact, we probably should run all tests. We did run all tests. We compiled, so everything looks fine. Okay, so that's good. This might be a very short video then, because I think we have done the removal Boost. Yeah, actually, I know what I wanted to do. I wanted to do a quick grep, just to double check that we didn't miss anything. As you can see, we didn't. So okay, so let's just then say probably a good time to end as well, because I can hear a lot of noises. Pause for a second. Okay, so what we're going to do then is we will just commit what we've got. I think it's probably enough for this video. It's going to be a very short one, but the video at least is very focused. We will just finish with CLI orchestration, remove boost DI, and I think that is the end of that. Okay, thanks very much for watching.